That's the wrong one too. Sorry. All right, so we're going to distribute the 5 and the -2 first. I can't do what's in parentheses. That's a 4R, that's supposed to be a 7T. I know it's kind of messy. So I can't subtract those. They're not like terms. So 5 times 4R is 20R. 5 times -7T is a -35T. -2 times 10R is -20R. And -2 times positive 3T is a -6T. Looking for like terms. 20R and -20R are like terms. What happens to them? They cancel out. They're additive inverses, right? Gives us 0. And then -35T and a -6T would give us our answer, a -41T. Make sense? Pretty easy, right? Just a little bit of practice, warming up, getting used to doing some math again. It's been a while. Oh, come on. Looks like it froze up on me again. So I'll have to restart it. That one. Don't worry about changes. Let's go find it again. Chapter P. And this is P2, day 1. All right, so the other one, 106, if this thing pops up again. There we go. 106, we had multiple grouping symbols. So when you see that, you have to work from like the innermost out. Okay, so I have these brackets. Those are grouping symbols, and I got these parentheses. They're grouping symbols. I go to the parentheses first, the innermost. Can I subtract 2 from 3x? No. No exponent, so then I go to multiplication, which is right here, and distribute. So -4 times 3x and -4 times -2, positive 8. Here I got like terms. So now I'm looking at the brackets, my grouping symbol. And that's a -10x when I combine those like terms. And then some of you do everything right to here, and then you get careless and you make that a 9. Is that correct? No. You got to do 3 times that. First, distribute the 3. Don't add before you multiply. So -30x and positive 24. Now we can combine like terms. I have a positive 6 and a positive 24 I can put together and get positive 30. So that's what you should get if you worked on those. Any questions? Okay, making sense? Good. I want to go over 55, 60 and 65 with you, just real quick. Making a number line. And 55 was negative, or was it positive 1, I think, wasn't it? Positive 1. And -2, I think. Did I remember that right? Or -3? 2? Thanks. Okay, so this is called, in the red here, is called interval notation. and they wanted us to graph this set that ends up happening. So what I do is do each one separate, and then I put them together. So from +1 to infinity, the parentheses tell us that we're not including that number, so it's a circle, and towards positive infinity. And then this is the same deal. -2 to infinity, we're not including the -2, so it's a circle, and towards positive infinity. Union means to put the two together. So when I put those two together, what's the graph look like? Just putting that together with that. Right, it would just be the -2 on, right? Because it would, when I put it together with that, it just kind of takes that up, right? Just gobbles it up, I guess. If this was intersection, I'd be looking for where they overlap. That would be from here on then, right? That's where they start overlapping, right here above the 1. Okay? So it just depends what you're being asked to do. The green one, 60, was -infinity to 1, and then the bracket means including the 1, intersect of brackets, the 1 to infinity, like that, wasn't it? Okay, so when I do that, I have a circle at 1, and going left, solid dot at 1, sorry, and going left, bad arrow, huh? And then here a solid dot at 1, going right. What's that mean again? What they have in common, right? Where they overlap. Where do they overlap? Just at the 1, right? So, down here, it would just be a dot at 1 on your number line. Does that make sense? And then 65 was in, let's do change colors, was in set builder notation. So remember, it always starts like that. And I think it was x is less than what, 3? Do you remember right? -3 and 2. And again, we're doing the union of those two, okay? So -3 would have been here, less than, do that, and 2 here, and less than that, and the union is putting together. So it would be this blue circle at 2, and then all of that. So very similar to the first one. It's just written in step over notation. So that was just a little exercise to get you used to looking at understanding what interval notation meant and understanding what step over notation meant. Let's do it there. Does that make sense? Questions?
Hi.
Hello. Thank you. Is it working, huh? Is that better? Aren't you guys telling me? Might be hard to hear on the screen cast, but. All right, so that was those 3. 70 was just plugging in numbers and finding the answer, which was 9. 75 was 13. 80, they changed the order on each side, so that's the commutative property of addition. For 85, they just multiplied by 1, which is the identity property of multiplication. And 90, they just put 3 in place of the x, so that's called substitution property of equality. 95 is 3x plus 6. 100 was 4a minus 2. 105 was 21a plus 6. Any questions on any of that? And then the last one, they gave you a little formula for circulation, and N was the number of months, so you put 12 in for N and figured it out. You should get 11.5, but if you change it to how many subscriptions, that's 11,500 subscriptions, because that was for per 1,000 subscriptions, so 11.5 is 11,500. But if you had 11.5 or 11,500, you did it correct. Any questions on that? All right, you guys are so smart. This is easy. Making it easy for me, right? Okay, today we're going to talk about some. Oh, I don't have it. I'm going to throw that paper away because I didn't think I needed it. Let me find it. Just put it here. No, I didn't put it in the recycle bin. We're going to talk about properties of exponents today. So, oh, I'm on the wrong page. Maybe that's why. Maybe it is there. It's here. Never mind. There we go. So, b to the nth power. B represents the base, n represents the exponent. That tells us, the n tells us how many times to multiply the b by itself, right? So, Mr. Myers, what's 3/4 of the third mean?
Take this to the third power.
Yeah, 3/4 times 3/4 times 2/4. Everybody understands that, right? And then you do 3 times 3 times 3 is 27. And 4 times 4 times 4 is 64. We're all okay with that, right? And again, you can put it in the calculator, right? But just remember what it means. What's the difference between those two? Which one's negative? The base is negative. Which one? The top one or the bottom one? The bottom one. The base is negative. This top one, the base is positive, right? We just have a negative out front. So this first one means negative, I guess, times, and 5 times 5 times 5 times 5. But this one means negative 5 times negative 5. You guys see the difference? So the top one would have been a negative 625. The bottom one would be positive 625. An even number of negative signs is positive, right? You guys see the difference between the two? Understand the difference between the two? Okay, and again, you'll probably put in your calculator. Just make sure you put in your calculator correctly, right? What's anything to the 0 power? 1. Very good. Not 0, but 1. So, what's 3/4 of the 0? 1. What's negative 7 to the 0?
1.
Negative 1. Because it's just the 7. It's like that first 5, negative 5, 1. How about this last one? 1. Yeah, it's still 1. Because no matter what this ends up being equal to, when you take it to the 0 power, it's 1. Okay, so that's a rule you got to remember. Again, you guys knew that, just needed to be reminded. Okay. When I have a base raised to a negative power, that means reciprocal. If I have 1 over a base raised to a negative power, reciprocal. Just flip it and it becomes positive. Okay? Becomes positive. That's how we want to write our answers, with positive exponents. If you have an answer with a negative exponent, whether it's a fraction or a whole number base, change it to a positive. So something like this, just do what with this so I can turn that to a positive 3? Flip it. Reciprocal. Okay, and then do the problem. What's 5 times 5 times 5? Thanks, you guys. right on. Negative 2 times negative 2, negative 2. Negative 6, right? No, negative 8, right? Again, you can just put it in your calculator, right? That's okay too. Negative 2 divided by 5 to the negative 3. It's going to give you a decimal. You guys remember how to change a decimal to a fraction on that calculator? Anybody remember? All right, let me show you again. Hit math, and that will change the answer to a fraction. That's what that means. So hit enter twice, and it'll get us the negative 125 over 8. Okay? Anything to the 0 power is? 1. This answer is? Negative, because that negative up front. If it was in parentheses, then it'd be positive 1. All right, properties of exponents. Again, I'm going kind of fast. If you need me to slow down, I will. If you don't, if you're okay, I'll just keep going. You okay so far? Again, I post this, sorry. I'll have the finished one as well. And then the screencast file will be on there too, if you need to go back and maybe watch a part of it. So, if I have the same base, b being the same base, 2 different exponents, and I'm multiplying them, all I have to do is write the base and add the exponent. So like if it's 2 to the second times 2 to the third, it's 2 to the fifth. Okay. For multiplication, what I do is look for where the higher exponent is. If the higher exponent's up top, then the b would stay in the top, the base, whatever it is. And then I subtract. If the higher exponent's in the bottom, then I put that base in the bottom, and then I subtract, biggest minus smallest, and always get positive exponents then. Okay? If you have an exponent inside the parentheses and one outside, you're raising a power to a power. We say that's what the name of that property is, power to a power. Then we multiply the exponents. So if it's 2 squared to the third, then it would be 2 to the 2 times 3, or 2 to the 6. So if this is 2 squared and that's 2 cubed, it's 2 to the 5th. If that's 2 squared and that's a cube, then it's 2 to the 6th. Okay? If you're not sure, you can always write it out long ways and then count up how many you got. Because you know what it means, right? 2 squared means 2 2's. To the third power means 3 of those, right? So 2 2's, 2 2's, 2 2's. Add them up, you're going to have 6 of them, right? Here, 2 2's there, 3 2's here. Add them up, 5 2's. Okay? You can always go down to the very basics if you have to. If you have a fraction with exponents and then an exponent out here, just remember, everything inside the parentheses is raised to that power. All right, so if that's a 2 squared and that's a cube, that's 2 to the 6th. If that's a 3 squared and that's a cube, that'd be 3 to the 6th. If there's more than one variable, you do that as well. Again, just review stuff. So, what do I do first in this? We'll just kind of do this one together. What should I do first? Can I do anything inside here? Like 5x squared y. Can I make that any simpler? Can I do any math in that? No. No. So I'm going to take all of these 3 things, these 3 terms. It's actually one term, but these 3 parts of the term to the second power. So what's 5 squared? 25. What's x squared squared? 4, right? Multiply them, 2 times 2. And then y squared, right? 1 times 2. Negative 4 to the third. Negative 4 times negative 4 times negative 4. Negative 64. X to the 9. Multiply. Y to the 15. Okay, so since there was no symbol between those two, what do I do with these two quantities? What do I do with these two answers now that I've simplified those two quantities? Is it addition, subtraction, multiplication, division? There's no symbol between this parenthesis and that. What's that mean to do? Multiply, right? You want to multiply these. What's 25? These are coefficients times negative 64. That's what you'll get. But what do I do with these x's and these y's now that I'm just multiplying? I'm going to do what? Add the exponents. Yeah. So x to the 13th and y to the 17th. Questions? Okay. Starting to remember, we haven't done this for a while. Get back in the math groove a little bit. What do you see? What should go make, I guess, what should make a little bulb go off in your head? The negative exponent. So what should we do first? Flip it, yeah. And what do we do with the negative 2 then? Positive now. Don't forget that. That's the reason we did it, because it was negative. We wanted to change it to positive. Now, everything in the numerator, I'm going to raise to what power? Second. And everything in the denominator, what am I going to raise it to? The second. Okay? Sometimes we forget to take the coefficients to the second power. Right? So 6 squared, p squared, q to the 8th. Supposed to multiply the exponents, right? 4 squared, p to the 4th, q squared. Any questions on getting to that point? Why I got something? Is it finished? Mm-hmm. No. You have to simplify fractions, right? Always reduce to lowest term. Okay. So, what number goes into 16 and 36? 4, right? 4 is the biggest, right? So, 4 goes into 16. 4 times 4 goes into 36. 9. There's my coefficients. Now, here's what I do. I look for the higher exponent. Where's the higher exponent for the p's? Bottom. So the p goes in the bottom. What do I do with those exponents? Subtract 4 minus 2. The q's, where's the higher exponent? Top. So the q, I write in the top and then subtract 6. Now we've finished it. Those two examples make sense to you? Little practice. We're going to do a few problems like that tonight. Okay? And the last type is scientific notation. Okay, scientific notation, it's always some number times 10 to an exponent. That n, that exponent, could be positive or negative. Okay, John? That's okay to have negative exponents in these. Okay, it wasn't in the last two we just did. This is telling you, this little inequality is telling you that the number that I'm multiplying by 10 has to be between 1 and 10. 1's okay, 10's too big. If it's 10 or bigger, you got to change it to a number smaller than 10. And all you do is move the decimal point to do that. So you got this 23,700,000,000, right? That's a big number to write. So scientific notation is like a shorthand way. Right now, where is the decimal point? Way back there, right? Where do we want to put it though? Between the 2 and the 3, yeah. Make it be less than 10, right? Then all the other numbers you need to put in there. You don't have to put the zeros, but you need to put the 3 and the 7. You can't just round it either. Make it 2.4. Right? Then we have our times 10. And then we count. There's where we have it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to move this decimal point 10 to the right. So is that a positive exponent or a negative? Positive, right? So that should be 2.37 times 10 to the 10th. Correct scientific notation. Coming back to you? Yes, no, maybe? Yes, good. Here's a small number. You can see our decimal point. We need to put it between the 1 and the 2. Okay? So we moved it to there. We're going 1, 2, 3, 4, 5, 6. So what type of 6 is it? Negative 6, yes. Okay? You have a couple problems where they're going to make you multiply 2 numbers or divide 2 scientific notation numbers. Couple problems like, here, let's do this. Get rid of it. Okay? Now, you can just put it all in your calculator like that. Your graphing calculator will do it. If you're doing division, make sure you put the parentheses around it now before you hit that division. So parenthesis 1.4 times 10 to the 5th, parenthesis, close it off, divided by, and then there's 2 more parentheses. And it'll do it for you. But it'll give you whatever the number is, E, and then it'll give you the exponent. Okay, it won't be times 10. It'll be using E. That's okay. All right, but that's what that means, times 10. I don't do it that way. I just do 1.4 divided by 2.8, which is real easy to do instead of writing all the other stuff down. 0.5, so I just put 0.5 times 10, and you just subtract. Always subtract top minus the bottom. So what's 5 minus negative 6? Negative 11? 5 minus negative 6. What do you do when you see minus a negative? Make it that, right? Is that right? Would you get full credit for me on the quiz Friday? You should be shaking your head this way or this way. Not this. No, I would not give you full credit. What's wrong with that answer? What must be true about the number in front of the times? You got to move that over, don't you? 0.5 is less than 1, right? It's got to be 1 or bigger, 10, less than 10. So I move it over 1. So it's 5 times 10. Now let's think about this. Here's where it was. We're supposed to move it 11 places, right or left? Which way? You tell me. Right, because it is positive 11. I'm supposed to go from here 11 to the right. Well, I just went 1 to the right. So how many more to the right do I need to go? 10, right? Everybody does everything right there, then they kind of get mixed up sometimes. And what make it, 10 or 12. Think about it. This one, I would just do 4 times 6. You guys all know it's 24. And add, what's negative 7 plus 3? Negative 4. Is that correct? No, 24 is bigger than 10, right? So we're going to Remember, here's the decimal point, we're gonna move it back this time. Okay, so when it was there, I was gonna go 4 to the left. I just went 1 to the left, so how many more to the left? 3, right? So that's -3. If you were to put that in your calculator like that, here's what it would look like in your calculator. That E means times 10. Whatever comes after the E is your exponent for the 10. All right, so that's the type of stuff you're going to see tonight for your homework a little bit. Okay? Any questions? Get it? Got it? Good? Look good? Feel good? You are good. You guys are awesome. 354 by 3, 3, 6, 9, 12, 15, and so on. Any questions? I need to stop sharing for a sec, and then I'll put it back up here for you.